My name is Chris Santiago, VP of Solutions Engineering here at Unravel Data. Throughout my 7-year career at Unravel Data, I've had the luxury of working with some of the largest data customers, maximizing their return on investments on modern data stacks like Databricks. Today's topic, mastering cost predictability, forecasting and budgeting strategies for Databricks. The key to maximizing your Databricks ROI lies in strategic forecasting and budgeting. Organizations implementing robust forecasting and budget practices for their Databricks environment can achieve significant cost savings while maintaining or enhancing performance. This presentation will provide actionable strategies and best practices to transform your approach to Databricks financial management. First, let's understand the Databricks cost challenge. Well, Databricks provides unmatched capabilities for data processing and analytics, but its cost structure is inherently complex. Costs are driven by Databricks units, or in other words, DBUs, which vary based on workload complexity, cluster configurations, and runtime durations, making it difficult to predict monthly expenses. Without proper management, organizations often encounter unexpected cost spikes that hinder their ability to scale projects effectively. This complexity underscores the need for proactive strategies to monitor and optimize usage. Now, why organizations struggle with cost? Well, one of the biggest challenges organizations face is the lack of granular visibility into what is driving up costs within their Databricks environment. This issue is often compounded by data silos, teams often operating independently, leading to fragmented cost tracking and reporting. As a result, many companies rely on reactive measures, such as cutting resources after overruns occur, rather than proactively optimizing for usage. This reactive approach limits their ability to forecast and budget effectively, creating inefficiencies across the board. Now, there is a lot of value to having proper forecasting and budgeting within your Databricks environment. Now, going beyond cost control, forecasting and budgeting go beyond simply just managing expenses. They empower organizations to allocate resources strategically based on business priorities. By predicting future spending patterns, teams can plan initiatives with confidence, ensuring that resources are available when needed. Additionally, these practices allow organizations to monitor performance against financial targets, fostering accountability across departments. This alignment between financial goals and operational execution helps drive long-term success. Now, Databricks specifically, in Databricks environments, effective forecasting ensures that cloud resources are utilized efficiently, avoiding both over-provisioning and underutilization. For example, teams can plan workloads more effectively by modeling DBU consumption ahead of time. This reduces the total cost of ownership while maintaining high performance levels for critical workloads. Furthermore, aligning technical capabilities, such as compute power or storage, with financial objectives ensure that every dollar spent on Databricks contributes directly to business outcomes. Better forecasting and budgeting improve cost predictability by enabling organizations to anticipate future expenses based on historical usage patterns or workload demands, reducing the likelihood of unexpected cost overruns. With tools like budget alerts and scenario modeling, teams can proactively adjust resource allocation to align with financial goals, ensuring spending remains controlled and predictable. Now, the key challenges for achieving better cost predictability. Let's break this down into 3 main groups. The first challenge is complex pricing and cost attribution. So Databricks uses a pricing model, as we talked about earlier with its DBUs, which can vary depending on workload type, the cloud provider, region, instance size, the service type, like serverless. This complexity makes it challenging to forecast costs accurately. Additionally, organizations often struggle to attribute costs to specific teams or projects due to limited granularity in reporting tools. For example, when you see total workspace costs, breaking them down by individual jobs or departments require manual effort. The second grouping here is inefficient resource management, which is a key challenge for better cost predictability. One common issue that I see a lot in my experience is over-provisioning resources. So allocating larger clusters than necessary for the workload, which unfortunately leads to unnecessary spending. Another one would be misconfigured autoscaling. That's another culprit. While that improves performance, it can increase costs significantly if not optimized correctly. Idling resources, another major concern. So especially when those all-purpose clusters are left running without active workloads. Now, you can implement features like auto-termination and even cluster pooling to help mitigate those inefficiencies. But let's also not forget about another cause of inefficient resource management that often gets overlooked: poorly configured code. Coding inefficiencies like SQL queries that are doing full table scan on partitioned data, or if most of the work is being done on the driver. Think of like those data scientists running those Panda libraries where all the work is being done on the driver and the workers are just sitting there doing idle. These also can show up as idle resourcing that also need to be addressed and also hinder organizations for better cost predictability. Last but not least, lack of proactive spending controls. So Databricks does not offer a robust built-in tools to set spending limits or receive real-time alerts for budget anomalies, and that increases the risk of cost overruns. This is particularly problematic for organizations managing large data sets or scaling their workloads rapidly, as storage costs can spike unexpectedly. Now, to address this, companies often turn to external cost monitoring tools or implement FinOps strategies to maintain better control over their Databricks spend. Now, those are the key challenges. What I'd like to do next is talk about those key challenges, but do it in a way on if you were to use Unravel to address some of these key challenges to attain better cost predictability. What you're seeing on the screen here right now is Unravel in action in a Databricks environment. Now we're connected to multiple workspaces here. This is just my playground environment here. And some of the things that we can do here is group by a time window. Right now I have this set to last 90 days. I can also look at things in terms of a specific chargeback type. So I can look at things at the cluster level. So all the other services from that standpoint, we can start looking at it from a cluster type. If we want to go even more granular, we can go ahead and select this job run. Now, this job run is also taking into account some resources that may be shared. So think about those all-purpose clusters that are supporting ad hoc queries or even some jobs as well. Getting down even granular really helps teams really understand usage at a fine-grained level. This also helps with some of the challenges of complex pricing and cost attribution. So being able to get down to the job run is key. The other thing is I've actually defaulted down here to the user level. So we're getting even more granular. So when we're starting to look at how we want to track maybe some of like the spikes in usage, I can get down to that user level and as well as the job runs to really start getting a really good sense of, where spend is going. Now, if I can point your attention to these next two panels here, the left one here is talking about DBUs. So that Databricks unit cost, right? That tells a story. And I can see that we've got some users that are taking up significantly more spend than others. On this middle one here, this is what we call the all-in cost. Now, for folks that are trying to do cost attribution, they're challenged in many ways because Databricks will show up as a line item, VMs will show up as a line item, ingress egress will show up as a line item, and a lot of that could be attributed towards Databricks spend. Today, if you were to do this, a very manual process. But within Unravel, right out of the box, we actually make that attribution and we represent that in that all-in cost. So when we're looking at things at a job run level, at a particular user, this all-in cost is talking about the DBU spend. It's talking about any other infrastructure that was dependent on this, so such as clusters, things of that nature. And it's all rolled up into one cost. So I can actually start seeing who are the top spenders in my time window here, right? Right out of the gate or right out of the box, you can get this information. So being able to demystify the complex pricing and cost attribution that can happen when folks are trying to understand that, you get this right out of the box to help with that better cost predictability. Now, the next topic I want to tackle here is inefficient resource management. How can Unravel help there? Well, let's take a scenario here. So what I'm going to do here next is I'm going to go ahead and sort by cost, and I can see that my user over here is taking up about 25% of my cost. That's pretty sizable. Now, in order for us to figure out what is inefficient, I'm going to go ahead and click on this Optimize tab here, which takes me to the list of jobs for that particular user in that time window. And let's actually focus in on the inefficient jobs for this particular user. So now I'm looking at the inefficient jobs, and what you're seeing here is a list of clusters that were deemed inefficient. Let's go ahead and pick one as an example here. So I'm going to go ahead and just filter on this node right sizing here. And I'm going to go into Spark here. And just to call your attention, this analysis tab is Unravel's purpose-built AI trying to find inefficiencies, if there are any, and if so, what are the recommendations to address? In this particular case, Unravel found an efficiency insight, more specifically, a save with node right sizing recommendation here. And what it's telling us here is that we could save some money. In fact, at the driver, we can save 6%, a little over 6% on this option one here, and we can save about 56% with this particular option. Now, if we're looking for that common overallocation inefficiency, one, Unravel is not going to waste your time by not telling you things that are inefficient. It's pinpointing specific, in this case, clusters that have inefficiencies. And we're also helping fast track actually right sizing this by giving the user very crisp recommendations in terms of make this change to save this particular type of cost. So for organizations that are struggling with the expertise to find inefficient resources, well, Unravel is doing that out of the box for every single one of your jobs in your environment today. Let's take a look at some other examples here. I'm going to go ahead and click on this Optimize tab. And in here, I can see, let me go ahead and zoom out here for that same last 90-day window. We see another one here where I can point your attention to this auto termination timeout. Now, we talked about some all-purpose clusters that are sitting there. In my experience, a lot of times I see folks that will set that to 60 minutes, maybe because there could be some jobs that they want to make sure that this cluster is always up and running. But at the same time, if there's a certain amount of time, let's go ahead and auto terminate. Well, Unravel, because we're looking at all the jobs in all of your workspaces, we can actually make a recommendation on auto termination. So in this particular example, this cluster was set for 20 minutes auto termination. But based on historical analysis, what Unravel has determined is we can actually save costs by reducing this down to 10 minutes. And this analysis is done to understand what are the times when people are actually using the cluster itself. And we can actually make a very intelligent recommendation here to say, you know what, 20 minutes is too long because this cluster, it really, most of the work is done within 10-minute increments. And then after 10 minutes, that's when it seems safe to shut down the cluster. Now we're doing this across all of the clusters here. So here's yet another example for us to be able to get in front of inefficient resource management, in this case, for all-purpose clusters that may have some auto termination setting. Last but not least, let's not forget about code. And so one of the things that I want to do here next is actually look at a common example, which would be just slow SQL, right? Here, what I'm going to do is I'm actually going to go ahead and click on this slow SQL job compute. And let me go ahead and go back over here just to make sure I've got my thing correctly sized here, sorry. I'm going to go ahead and hit the slow SQL over here. It takes me to this particular job. Now, what Unravel's doing under the covers is we're looking at, in this case, a Databricks job, which was using Databricks workflows. And if I go into this bottleneck insight here, here's Unravel actually detecting that there is an inefficiency. And in this case, there's a slow SQL event. A slow SQL event stage is triggered when scan or join operation delays are detected, which are increasing query execution time. If we want to get some more details on here, we can actually go to the impacted runs here, and we can see what that symptom is here. And here Unravel is actually detecting a slow SQL operator. This scan object is detected in this job, and it's wasting 5 minutes and 26 seconds. So if we want to actually address that, we can go to this remediation tab here, and out of the box, Unravel provides some actionable insights here. So optimizing for scan operators by optimizing the task by tuning this configuration parameter, or optimizing for shuffle operators by providing this configuration parameter, really helps address some of the common code issues that your users can use to better improve performance and, more importantly, reduce inefficient resources by looking at things that can only be addressed from a coding perspective. Very powerful stuff here. Now, last but not least, let's not forget about the third bullet point in keys to challenges for achieving better cost predictability. And that is really just the lack of proactive spending controls within the Databricks environment. Well, rest assured, built in from within Unravel, we have some proactive budgeting capabilities. What you're seeing here right now is our budgets tab, and we set a budget here. So if I actually go ahead and just look at what was set here, we can see that this budget was set for this particular time period. We're also setting up the scope. In this case, we're looking at things from global, but we could look at a specific workspace, or we could actually look at a specific user. And then from there, we can actually set the budget. And we can also set up a notification channel, which could be an email, a Slack message, could be a ServiceNow ticket. And then we're off to the races. Now, once that's actually set up, you'll notice that Unravel is detecting where we at in the budget cycle today. So right now we are, a few minutes or a few days into our budget cycle here. We're already at 6%, and you can see that it's green. Okay, that's great. Now, what happens when the budget is blown? Well, this turns into red, and we can get notified whenever these events change, whatever the status is. Another one, yellow. Now you would thinking, okay, what does yellow mean? Well, this is Unravel. This is where Unravel's predictive analysis kicks in. And based on usage patterns, on historical usage trends, what we can do is really understand, hey, if we are 16 days into our 30-day billing cycle, and based on how this is actually tracking, we're going to blow the budget if things continue to go on undiagnosed, right? This now provides you the ability for us to actually step in and tell some of the users, you know what, go to look at Unravel. Look at what Unravel deems as inefficient, and actually go ahead and tune the rest of the jobs so that way we can actually get that budget back from yellow to green. Think about that. Being able to actually course correct budgets before they go over budget before the billing cycle. That has helped bail out a lot of my customers who are tracking costs. One last other thing that we can do too is setting up what we call auto actions, which is Unravel in real time looking for some sort of anomaly. And so what we can do here is we can actually look at something like a job run. So we can actually set up an alert for maybe if a run was running for maybe 8 hours, or maybe I want to do this from a cost perspective. Maybe I have a really set goal and I really don't want jobs to ever cost $1,000 because that's an extreme anomaly for me. Well, Unravel can actually detect this as the jobs are running. And then from there, be able to actually do some sort of action, whether that's setting up an email. We can use the HTTP post to actually kill jobs. We could also even set some alerts to Slack, Teams, or we could even post to an ITSM like a ServiceNow or PagerDuty. All of this becomes built in into Unravel itself, so that way we can really bridge the gap from the lack of proactive spending controls that are based in that you don't get from a Databricks environment. All right, so we covered a lot of detail here. What we covered so far is that having better cost controls and better predictable spend is going to really greatly improve your ROI of your Databricks spend. We talked about some of the gaps, the key challenges to getting better cost predictability. And then we did a demo to walk you through how we can actually solve for those challenges. My action item for you, why don't you go ahead and get your free Databricks health check by visiting this URL here. And by doing so, you can do this by looking to see if Unravel can unlock 50% more workloads for your same budget, identify eliminated wasted spend on storage and computing, and ultimately increase the productivity of your data teams, all for free. So go to this link. I encourage you to go to this link and try us out and see if this actually solves the needs that you're looking for better cost predictability. All right. Next, what I'm going to do here is I'm going to go ahead and look at the here we go. This is my going into the chat to see if there's any questions here. I see one here. So how can historical data be effectively leveraged to improve the accuracy of future cost predictions in Databricks environments? Well, Unravel improves Databricks cost prediction by analyzing those historical usage patterns, as we just saw, attributing costs at granular levels like that charge rack report, and applying AI-driven models to forecast future expenses. Unravel identifies Unravel identifies workload trends, detects anomalies, and refines predictions using real-time feedback, ensuring accurately forecasts and actionable optimization recommendations. This approach enables organizations to proactively manage budgets, optimize resource usage, and maintain high prediction accuracy in complex Databricks environments. Hopefully that answers that question. I see another one here. How does your solution address some of the most common challenges that my organization faces when trying to accurately forecast spend? Well, Unravel data addresses these common cost forecasting challenges by providing granular visibility into costs at the app, user, cluster, or even service levels, enabling precise chargebacks and anomaly detection in near real time. Our AI-driven platform leverages historical trend and predictive analytics to forecast spending accuracy while automating recommendations for things such as right-sizing clusters, workload optimization, fixing code issues, and ultimately governance, helping organizations reduce costs and maintain budgets effectively. I see one more here. How does your solution help highlight the key metrics data management experts should focus on to transition from reactive to proactive cost management? Well, our solution highlights key metrics to help data management experts transition from reactive to proactive cost management in Databricks by focusing in on that granular visibility. We're leveraging those predictive analytics and ultimately providing actionable recommendations. This is also emphasized by tracking costs at that app user and cluster level, monitoring resource patterns, and forecasting future expenses through that budgeting report there, using historical trends and offering AI-driven recommendations for workload tuning, code optimization, and cluster resizing to prevent overspending and improve efficiency. Alrighty, that's all the content that I have out here. As always, my name is Chris Santiago. You can reach me at chris@unraveldata.com. I look forward to seeing you guys at a next webinar. Thank you for your time, and you have a good day. Thank you.